Here I have a small mold project, and I want to be using the Opti Rough series of high-speed toolpaths to machine. Now this is a solid model of the mold core. It's a standing boss. This is going to be a candidate for the Opti Core toolpath. We'll find that under Toolpath, Surface High Speed, and then you'll notice Opti Core, Opti Area, and Opti Rest. This part is going to be using the Core toolpath, and then I'm prompted to select my drive surfaces. Now the general strategy with the high-speed surface machining is to select the entire model as a drive surface. So I'm going to go into solid selection mode, turn off face, but have select body turned on, click on the model, OK, and it shows I have 42 drive surfaces. These are all the various faces of the solid model. Since I pre-selected Opti Core, this is highlighted. If I change my mind, I could easily select different toolpaths right here. We'll leave it on Opti Core. Onto Tool Selection. Now we're going to see these toolpaths are very unique. The general strategy for using them is use a smaller diameter tool than you might traditionally, but use a very fast and light feed rate. So with the traditional toolpath, I might use a 3/4 or a 5/8 end mill. But with this part, I'm going to select a 3/8 end mill. My feed rate is going to be pretty quick at 200 inches a minute. Now these fields here are extremely important to be setting. This is really what make or breaks your success with these high-speed dynamic type of toolpaths. So the key to using these is having a large step down. Generally, twice the diameter is no problem at all for these toolpaths, as long as we have a step over that's very light, and usually it's between 10 and 20%. I'm going to have 15% here, middle of the road. That shows me I'm having a 56,000 step over, so it's a light XY step over, which we can see step over in the picture here showing me what that step over is as far as the terminology. The final key to this is the toolpath radius. And I click on that field, and it shows me what that is. That's the actual radius that the toolpath cuts in the corner. This toolpath will never go in and use the full radius of the tool. It will always make an arc motion. That's what makes it possible to feed at an extremely high feed rate comfortably. So the toolpath radius, this generally is set between 20 and 40%. Let's just set this to 30%, middle of the road here. So in any corner situation, it's going to be cutting 112 thousandths radius. We're going to see this when we backplot the toolpath. So these three fields, step over, step down, and toolpath radius, are the keys for any dynamic milling. Now the Opti toolpaths also have step up. If I turn that on, click in the field, you can see a picture here. Now the way these toolpaths work, it takes the large step down of 3/4 of an inch. After it does that and evacuates a lot of material, it's going to be taking step ups to smooth the model out. And I'm going to set this pretty fine here, let's say 10%, so 37 thousandths. So now that I have my key features set for my Opti toolpath, I'm going to go through and set some of the other ancillary settings. So the back feed rate, this is when the tool is repositioning and not cutting. Set that to 500 inches a minute. And I'm going to leave about 15 thousandths on the wall and the floor. And now my cut depths, go into steep shallow here. I don't want to cut all the way down to this part. I just want to cut the mold part. So Z depths, my maximum depth, right click, Z coordinate, pick the floor of the mold, so -1.25 inches. Minimum depth, Z0 is the top of this part. I'm going to give it a little bit more to cut up top, so I'll give it 75 thousandths. Go down to my linking parameters. There are quite a few different settings in here, and usually if you go with the defaults, you're going to get a good result. The only one that's extremely important is this setting here, what the tool is doing when it's repositioning around the part. We have several options here: minimum vertical retract, full vertical retract, or generally the preferred minimum distance. This will output XYZ move the shortest distance. Now it's extremely important that this output feed move is turned on. So this will be a G01 programmed feed move. The Mastercam will always maintain control over the cutting tool. If we turn this off, what's going to happen here is this is going to turn into a G00 move, and Mastercam is going to pass control of the tool over to the machine. And we don't know how that machine handles rapids. For instance, does it move Z first and then XY? Or does it run at a rate so the tool arrives at the program destination simultaneously? Not knowing these factors is a recipe for an inevitable crash. Having output feed move on always maintains a programmed relocation move. The last page I'm going to go into is the arc filter tolerance. Now this is a roughing toolpath, so I don't have to cut it to a really tight tolerance. I'm leaving 15 thousandths on the part, so I'm going to give myself a 10 thousandths tolerance. I'm going to refine the toolpath, and another key here is to make sure the line arc settings are turned on, so I can get arcs in the XY plane. The minimum radius has to be set to at least what my cut tolerance is. So that's 10 thousandths. Everything else I can pretty much leave alone. And now let's backplot the toolpath. So what we can see is a very large step down. That's my 3/4 inch step down, but a real shallow step over. Now in this backplot, I have my linear moves as blue and my arc motion as orange. So this is going to be nice smooth machine motion, very smooth on the servos and the ball screws. Now you'll notice the detail. When the tool comes into a corner here, it's actually cutting a radius. It never will go into the corner and use the tool to form the radius, which would no doubt break at this feed rate and this depth cut. So that's the rounding radius we're seeing right there. Probably the most important feature in these high-speed toolpaths. So there's our 3/4 inch step down, and here's our step up now that we see. So this is roughing and semi-finishing the part with one toolpath. Goes down to our next large step down, and then steps up. Now if we go through a verify, now that's a nicely machined part, ready for some finishing operations without any other toolpaths added.